Hi, we are gonna be showing you a demo for the STEK cable tracer or the underground cable locator. So I'm gonna show you everything that the cable locator comes with in terms of accessories and the actual device itself. So here is the detector, and then this is the transmitter. This is the clamp that gets attached to the transmitter. This is the charger for the transmitter. This is the charger for the cable tracer receiver. This is the distal cable that gets attached to the receiver. This is a USB that gets attached to the receiver as well. These are the Crocodile clips that get attached to the transmitter with extra Crocodile clips as well here. And this is the earthing device. The transmitter has instructions on the lid here above it. When we see the transmitter itself, we can switch it on like this. Here is the socket for the output that could be attached to the clamp or the Crocodile clips. And you can change settings here. Because there's nothing attached right now, it is automatically on inductive mode, where the transmitter itself would transmit underneath. This is the default kilohertz settings. You could change it just by tapping here. And this is the gain. You could change the gain depending on your requirement and the amount of noise in your surroundings. This is the start button. When you click on start, it will start transmitting. But I'm going to show you this later on as to how to actually operate it in a real environment. Here's the setup. You can change all the setup here, although this would not be of much direct use in the beginning. I'm switching on the receiving unit. The receiving unit has 3 modes. This is the direct cable locating mode. This is the directional cable locating mode, which shows you the direction it is in. When the 2 green arrows come together, that means there's a cable underneath. This environment is indoors, so I'll be showing you exactly how to use this in an outdoor environment. And this is the sinusoidal waveform, which will show you any detection capabilities. If you press F here, you can change the frequency in green here. I'm pressing F and the frequency keeps changing. When I press M, you change the mode. If I long press it, it will go to settings. If you press I, you will return to the main menu, the main screen. If I press up, it will increase the decibel level for higher noise, and if I press down, it will decrease the same. If I press I, it will mark the cable successfully. For live circuits or live wires, you'd be using the clamp method, which is the most reliable method, or if you cannot get access to the clamp or the wire itself, you'd be using the induction method. Although the clamp method is the most reliable and most accurate method, you could also use the Crocodile clips if the wire or the cable does not have power. You can directly attach these to the conductor. But I'm going to be showing you the most used method, which is the clamp method, which comes with a cable like so, which you can attach in here and you can tighten it. And as you see, it automatically switches to coupling mode because the clamp has been detected. Hi, as you can see here, I am in Fort Mumbai. I have a lamppost in front of me, and I have a clamp connected to one of the cables here. and the clamp is connected to our transmitter. I'm going to turn the transmitter on. As you can see, the transmitter automatically detects coupling mode because the clamp is connected. It's currently at 3.2 kilohertz. I'm going to increase it for a higher frequency so that there is no noise involved. And I'm going to start the transmitter. As you can see, the transmitter is connected to the lamppost through the clamp, and I am all the way over here. I have the receiver in my hand here. I'm going to switch it on. Now, as you remember, we had set the transmitter to 32.7 kilohertz. So I'm going to press the frequency button till I get to 32.7 kilohertz. And as you can see, it is telling me exactly where the cable is underneath here. When the cable we've transmitted from is all the way over there, it is telling me the exact location over here. I can check it out in another mode as well. As I go this way, it tells me, the right arrow tells me that I have to go towards right. And as soon as I get two arrows, one on the left, one on the right, that means the cable is right underneath here. And as you see, if I move away, the amplitude goes lower. If I'm right on the cable, the amplitude is maximum as well. And it's showing me the cable is 0.25 meters underneath exactly. As you can see, it's on coupling mode right now because the clamp is connected. Now I'm going to remove the clamp. It automatically goes on to inductive mode at 32.7 kilohertz is what we had set it at. And now I'm going to click start. Now it's going to induce 32.7 kilohertz directly underneath where this cable is. Now, as you can see, I had switched on the inductive mode and there's no cable attached on the transmitter to the actual cable. It's just the transmitter inducing current underneath. I'm standing all the way over here. I have my receiver here. It's also set at 32.7 kilohertz. It's showing me exactly where the cable should be underneath here. If I go here, it's like, no, you have to go a little right. I come to the right. Both arrows are here. This is exactly where the cable is. Now, this method is not as reliable as the clamp method because we're inducing a current and there could be multiple cables underneath. But since there's only the one cable over here, we can be pretty confident that it is this cable. Another way of detecting the cable underneath, especially when there's no current flowing through and the cable is completely offline, is through Crocodile clips. Make sure that the circuit is off and the conductor of the cable is exposed. If so, you can connect the Crocodile clips to the conductor and the other end to the transmitter. The Crocodile clips and the transmitter will induce a current into the cable, and the receiver can then detect where the cable is underground.